Welcome back to Medical Neuroscience, and in this tutorial I'd like to give you an overview of the limbic forebrain. The core concept that will be germane for today's discussion is simply that the brain is the body's most complex organ. And I have two learning objectives for you today. First, I'd like for you to be able to review again the anatomy of the internal structures of the forebrain with a particular focus on localizing the amygdala and the hippocampus in the medial part of the temporal lobe. So as we'll see, this tutorial will revisit the brain anatomy lab with a focus on looking at slabs that have been cut through the forebrain to reveal the location of the amygdala and the hippocampus in the medial temporal lobe. So I want you to pay special attention to where you would find these structures, and I'd love for you to have a general sense of what these structures actually look like when it is possible to cut into a human brain. My second objective for you is that I want you to be able to discuss the major functions of the limbic forebrain. Now, much of the content that pertains to this second learning objective is found in the tutorial notes that I've given you. It's one of those notes that's available in PDF format in narrative style rather than outline style. But you'll also see that in a different tutorial here in Unit 6, I'm talking to you more generally about the neurobiology of emotion. And since much of the limbic forebrain pertains to the brain systems that are involved in emotion and in related aspects of cognition, these topics will be elaborated in more depth in that particular tutorial. So let this experience here today remind you of the anatomy of the medial temporal lobe, and study the tutorial notes, and then conclude Unit 6 by considering the neurobiology of emotion, and in particular how the brain's systems for emotion and reward can be thwarted by addiction. And that will be the conclusion of Unit 6, and indeed the final tutorial presentation in medical neuroscience. So, I'll see you in the lab, and hope you enjoy reviewing again the internal anatomy of the medial temporal lobe.
The purpose of this lesson is to highlight the relative position of two very fascinating structures that are found in the anterior and medial part of the temporal lobe, the amygdala and the hippocampus. And we're looking at two coronal slabs that are adjacent to one another. The slab on the left is anterior to the slab on the right. So let's first look at the slab that's on the left. And let's focus down into the anterior and medial part of the temporal lobe. So just below the basal ganglia, we see a large mass of gray matter accumulating. This is the amygdala. So here's the amygdala in the right hemisphere, and just across the midline we can see the amygdala in the left hemisphere. The amygdala is another one of those great anatomical terms. It means almond, not because of its shape, but because the amygdala is buried deep in the temporal lobe like the meat of an almond within its shell. So at this level we have the amygdala in the anterior medial temporal lobe. Now if we can look at the adjacent slab in the same anterior and medial regions of the temporal lobe, what we see is not an almond shape, but rather this curved bit of cortex that folds in upon itself. This is, again, the hippocampus. And at this level, the hippocampus is a broad structure that forms the floor of the lateral ventricle as it extends into the temporal lobe. So here we have the right hippocampus, and across the midline of the section is the beginning of the left hippocampus. So for the most part, the amygdala sits anterior to the hippocampus, but if we look carefully at this left temporal lobe, we can see that there is a bit of overlap. This is some of the posterior amygdala that sits just above, meaning just dorsal, to the hippocampus. So there is a plane of section where we see both the posterior part of the amygdala and the anterior part of the hippocampus, but much of the body of the hippocampus sits posterior, further back into the medial temporal lobe.